This video extends vector concepts from two-dimensional space to three-dimensional space. We begin to explain how to represent vectors in 3D space, and then some basic properties of vectors. If you find it necessary, you should watch the videos that appear in the upper right corner for a review before proceeding here. Thanks in advance for watching this video. If you like this video, don't forget to like and subscribe to the channel and activate the bell. It's very important for the continuity of this channel. We start with geometric representation in R3. 3D vectors are represented by directed line segments called arrows. The vector v, or vector AB, has an initial point A and terminal point B. The initial point is the tail, and the terminal point is the tip. The vector v, or vector AB, can be drawn geometrically by placing the tail at its initial point A and the tip at its initial point B. We draw vector v, or AB, as an arrow pointing from A to B. The component form of vector v is produced by subtracting the coordinates of the initial point from the corresponding coordinates of the terminal point. The vector v can be written in component form as follows. Part A is simple. We subtract the coordinates of the initial point from the corresponding coordinates of the terminal point. The magnitude or length of the vector is the length of its arrow and corresponds to the distance between the initial point and the terminal point, and is denoted by the symbol. By using the distance formula to compute the length of a segment, we obtain the following formula. Part B is simple as well. The length of vector v is the square root of the sum of the squares of its components. We now introduce some vector terminology. We say that u and v are equivalent or equal if they have the same length and the same direction, even though they are in a different position. In the figure, vectors v and u have the same length and the same direction. Therefore, they are equal vectors even though they have different base points. The zero vector, whose head and tail coincide, is the vector of length 0. It is the only vector with no specific direction. A position vector is defined as a vector that indicates the position of any given point with respect to any arbitrary reference point like the origin. The direction of the position vector always points from the origin of that vector toward the given point. We assume all position vectors are based at the origin of the 3D space. The particular representation OP means the position vector of the point P from the origin to point P. To solve part C, we locate the initial point and the terminal point, and then we draw the arrow from the tail to the tip. The position vector OA has an initial point at the origin and the terminal point at A. The position vector OB has an initial point at the origin and the terminal point at B. The position vector OP is equivalent to the vector AB, but the vector OP is based at the origin. Unit vector is any vector that has a length of 1 unit. The special notation for the unit vectors in the direction of the positive x, y, and z axis is these vectors I, j, and k are called the standard basis vectors, and any vector in R3 can be expressed in terms of I, j, and k as follows. Express vector v using standard unit vectors. Vector v is 7i plus 3j plus 3k. A unit vector u in the direction of vector v is given as follows. Find the unit vector in the direction of v. We apply the definition of a unit vector.